It's Thursday, March 31st, and we're remote because of all the chaos outside. So we are going to be using this mnemonic to work gas stoichiometry. And we've been doing this where we did mass to moles to moles to mass, but now we got gas volume, so we can use the bottom. And we'll be doing parts of the top today too. Remember, you're going to use the periodic table to turn grams to moles, the balanced chemical equation to turn moles to moles, and the periodic table again to turn moles to grams. We're pretty good at this. But now we have the option to turn volume to moles and moles to volume. So we can do this with gases too. Two ways to do it. One, you can put a volume in P, V, R, and T and find moles this way in one step. And come across here and do this. You could use PV equals nRT here. Turn your moles, that would be N would go into here. What you can also do is use the combined gas law, P1V1 over T1 equals P2V2 over T2, to convert to STP, standard temperature and pressure. Once you're at standard temperature and pressure, then you can use 22.4 liters per mole like we did in the lab, and then you can go moles to moles, and then moles to volume by using 22.4 liters per mole, and that will give you the volume at STP. If you're going to convert to not STP conditions, after you do that, you would start with this being at STP and convert to your non-standard conditions. Something that's not standard temperature pressure. Okay, so let's look at these. Page 461, number 38. How many liters of propane gas will undergo complete combustion with 34 liters of oxygen gas? Well, let me show you this. First of all, what aren't they telling you? They're not telling you the pressure. They're not telling you the temperature. They're not telling you the moles. So those things are going to be the same. We have to assume they're the same because nothing was said about it that I remember. So remember that these coefficients that go in here when you balance the equation, these are the molecules. Or in this case, every compound here is a molecular covalent compound. Propane's molecular covalent compound, oxygen's molecular covalent element, carbon dioxide's molecular covalent compound, water's molecular covalent compound. So these numbers count molecules. These numbers also count moles. And if the gas conditions are the same everywhere here, which they're not going to be, and if you burn propane in your furnace, like the one I have in the greenhouse, you're going to start with cool gas conditions and very hot, so you'd have to get them back all to the same temperature, back all to the same pressure. Then the liters are the same. 1 liter of propane and 5 liters of oxygen give you 3 liters of carbon dioxide and 4 liters of water vapor. In order for that to be water vapor, this would have to be over 100, so all of them would have to be over 100 degrees Celsius. Okay? They don't even have to be at STP. As a matter of fact, if they were at STP, that wouldn't be a liquid. Sometimes books write these problems with water and they want you to do STP, and the author isn't thinking, like every book I've ever used, they have a problem like that. But that's not this is ice water at 0. Okay, as long as these conditions are the same, that doesn't have to be STP, then these coefficients are the same. That lets us skip from here to here. Let me show you what I mean. Okay, so reading the problem again, I have to look for what I'm looking for. How many liters of propane gas? So we are going to go equals V liters propane. C3H8. So V equals blank liters C3H8. And I'm going to put what we know. And we have 34 liters of oxygen gas. O2 over 1. Okay, now, since it doesn't tell us what these conditions are, let's use STP. It doesn't tell us what these conditions are so we can make our own. Because all this stuff in the middle is going to cancel out, and we can go directly from here to here. That's what molar volumes is all about. So, wouldn't get in a big hurry to write all this down, because watch, it's going to cancel. Okay, so for every liter of oxygen, that's 22.4 liters is 1 mole. In fact, I'm not even going to label that for oxygen because that's true for every gas because of molar volumes. That's at STP, so I made it be at STP. And for every 5 moles of oxygen, you have, for every 5 moles of oxygen, you have 1 mole C3H8. Okay? Now, you had to, on your own, come up with this balanced chemical equation. Hopefully you didn't just write that down and you know how to do that. You should know how to do that. So every 5 moles of oxygen, 1 mole of propane. Now, if you look at what I'm doing here, I'm going liters to moles to moles to liters. Liters to moles to moles to liters. Liters to moles to moles to liters. That's my plan. Turns out you can go straight through there. And then I got to convert moles of propane to liters of propane. Now this is true for every gas. The following. 1 mole of any gas is 22.4 liters. And I don't need to identify the gas because that's true for all gases. Now look, what happens? This term is exact inverse. I shouldn't call it a term. These are exact inverses. So that cancels that, and we're skipping directly from volume to volume. Now we have to use the balanced chemical equation there to do it. But 34 liters divided by 5 should be 6 4/5, which should be 6.8. Which is what I have here. 6.8 liters of propane. These two are the same. So you can just eliminate it. Okay, on to 39. Determine the volume of hydrogen gas needed to completely react with 5 liters of oxygen gas to form water. So the first thing you should do is write the equation and balance it. I already have that done. Now on this one, you are going from liters to liters again. You have to go through moles to get there. But that will end up canceling out. You can actually go there directly. As long as the gas conditions are the same for the conditions. Now let's read that. It says nothing about the conditions changing. So we have to assume it's the same. They're going to change. If you burn hydrogen with oxygen, bang. Okay, so basically we're looking for, I think, liters of hydrogen equals V liters of hydrogen. V is equal to so many liters of hydrogen. And I'm starting with 5 liters of oxygen over 1. And I'm going volume to moles to moles to volume. But if the conditions are the same, I can just skip that step. Just like, because the reason why, you're going to convert it volume to moles, liters to moles, and then when you get over here, you're going to convert moles to liters. So they're opposites. It's just going to end up canceling. So I'm just going to go ahead and take it out this time. Okay. And then there are, remember these numbers, as long as your gas conditions are the same, are also liters. For every 1 liter of oxygen, I have 2 liters of hydrogen. Now I'm going to go ahead and make these numbers in red. Because they're not just molecules or moles this time, they're actually volume, and I'm getting them from the balanced chemical equation. So every one of these is 2 of those. 5 times 2 is 10. So there's the first couple problems down. And by the way, yep, those numbers were the same there. Okay, number 40. What are you doing this time? Well, you need the balanced chemical equation, so hopefully you have this written out without, too much help. You should know how to do that. What volume is needed to completely combust 2.36 liters of methane gas CH4? If you have natural gas, this is mostly what you're burning in your furnace. So we want liters of oxygen when we know the liters of this. So we're going to say equals V liters of oxygen. V equals so many liters of oxygen. And we're starting with some liters of CH4 over 1. Now, we could go volume to moles to moles to volume. But that's 22.4 liters in and 22.4 liters out. We know that's going to cancel because our gas conditions are the same. It doesn't say anything's changed on number 40. So we have to assume that's the same. So we need down here liters of CH4, which is 1, to liters of oxygen, which is 2. And we started with 2.36 liters. Okay, and oops, I have a mistake on the oxygen up here. This is supposed to be a 2. And that just doubles everything, so I think it should be 4.72 liters. Yep. Okay, the rest of them will work on another video. I don't know if I fit it all in.